This is Algebra 2, Lesson 4.8, which is on graphing inequalities. We're going to have graphing inequalities and we're going to have solving inequalities. So, graphing inequalities, these are all in standard form. We want to draw a dotted line for our axis of symmetry and graph our vertex. This is a nice easy one, y equals 2x squared. Remember that if we have greater than or less than, we draw a dotted line. Greater than or equal to or less than or equal to, we graph a solid line. So this one's going to be a dotted line. There's no shifting. This one we could consider in vertex form. So at 1, it's going to be up at 2. At 2, it's going to be up at 8. So it's going to be pretty steep. And then I'm going to draw a dotted line. If it's y is greater than or y is greater than or equal to, we shade up. And if it's y is less than or y is less than or equal to, we shade down. So this one is greater than, so my line is dotted, and I shade up. So we're going to end up with a graph that looks like that. All right, number 2. So my axis of symmetry would be negative b over 2 times a. So I'd have negative 12 over negative 4, which would be positive 3. Because these are not in vertex form, I'm going to graph them on my calculator once I find my axis of symmetry so that I can just quickly plot the points and then graph my inequality. So my vertex is up at 3, 1. So just using the calculator, plotting points, getting those quickly. This one's equal to, so it's going to be a solid line. And then it's greater than, so I shade up. So that's what number 2 looks like. Number 3. My axis of symmetry would be the opposite of negative 8 over 2 times a. So I'd have 8 over 2, which is 4. So x equals 4 is my axis of symmetry. Again, I'm going to use the calculator to quickly plot a couple points. For negative 3 is my vertex. We are back to a dotted line. This one is less than, so this is another dotted line. This is less than, so I shade below, I shade down. Sometimes because it's a parabola, people like to think about inside and outside. We can't think inside, outside. We still are up and down. Do I shade up or do I shade down? Okay, because we've got the parabolas that can go up and down, and so then we still have to go above or below wherever the vertex is. All right, the last one, graphing. My axis of symmetry is going to be the opposite of negative 10 over 2 times 2. So I'll have 5 halves. So this one's going to be an in-betweener. So it's going to be at 2 1/2. And again, it's in standard form, so I'm not going to waste my time doing anything else. I'm going to go to my calculator. So my vertex is at 2.5, negative 2.5. It's equal to, so it's a solid line. It's greater than, so I shade up. Quadratic inequalities, not much to them. All right, now these are solving quadratic inequalities. And with these, notice there's no y. Okay, with these we had a y in them, so this is what we're doing on a coordinate plane. These just have an x, and so what we're doing is we're solving for just for x. So these are going to be inequalities that we are going to write when we get done. Okay, so solve each inequality. What we need to do is we need to have our solutions. If we had x squared minus 8x equals 0, we would have to factor and solve and find our x-intercepts, our solutions. So I'm going to get x equals 0 and x equals 8. Those are my two solutions. So this is not equal to, so these are going to be open circles. Okay. Now you can do this a couple different ways. One, you can pick numbers. Pick a number that's less than 0, -5. If I plug in -5 in here, does it make this true? So if I plug in -5, I'd have 25 plus 40. That's going to be a really big positive number, so that's not going to work. If I pick a number between 0 and 8, I'll pick 1. If I plug in 1, I'd have 1 minus 8, which is a -7. Aha, that would make it true. And if I picked a number bigger than 8, say 10, I'd have 100 minus 80, I'd get 20. That's not less than 0, so that does not make it true. So my solutions are between 0 and 8. So we're going to say this is an and compound inequality. I'd have 0 is less than x and x is less than 8. Okay, so number 6, we need to factor. And I'm just going to factor quickly. So x equals a positive 1/2 and x equals a positive 1/3. Oh, hang on a second. Those are all positives. Just kidding. X is going to equal a negative 1/2 and a negative 1/3. Those are my two solutions. Okay. Now this one is equal to, so these are going to be closed. So this is going to be, now be careful, you have to put the one that's smaller. Negative 1/2 is less than negative 1/3. Okay. So now we have those three regions to test again. Okay. So we have something smaller than negative 1/2. Well, something smaller than negative 1/2 would be -1. I'd have 6 minus 5, which will be 1, and 1 plus 1 is 2. So that one works. Between negative 1/2 and negative 1/3, gross. This is about negative 0.5, and this is about negative 0.3. So if I did negative 0.4, that would work. And I'm definitely going to use a calculator for this one. So I'm going to take this one and I'm going to do 6 times negative 0.4 squared plus 5 times negative 0.4 plus 1. and we get a negative. So no, we want it to be greater than 0, so no, that does not make it true. Then I need a number bigger than negative 1/3, 0. So then if I plug in 0, I'd have 1 is greater than 0. Yep, that one works. And so this one is going to be an OR compound inequality. If you remember from when we did inequalities, you're going to have x is less than or equal to negative 1/2, or x is greater than or equal to negative 1/3. Number 7. In order to factor, I have to subtract that 8. So I have p squared plus 4p minus 12 is less than or equal to 0. So that factors into p plus 6 times p minus 2. So my two solutions are negative 6 and positive 2. So take a look at my number line. Equal to, closed, negative 6, positive 2. Test my regions, okay? So if I pick a number less than negative 6, now I have to use this one because 0 is the same as my number line. So I'm look for when it's positive and when it's negative. And I want it, in this case, to be negative. I want it to be less than 0. So negative 10. I'd have 100 minus 40, which would be 60. 60 minus 12, not going to be a negative. So that is a no. Between negative 6 and 2, 0. I would have negative 12 is less than 0. Yep, that one works. Bigger than 2, 3. I would have 9 plus 12 minus 12. Nope, not going to work. If you're starting to notice a pattern of how this is going to work, it is going to work that way all the time. So this is going to be an AND compound, and oops, I have a P here. I just realized I did that on the last one. I accidentally used an X instead of a V. So if you do that on the test, I'm not going to take points off if you accidentally write X instead of whatever letter that they gave you on that problem. Okay. All right, and there's one more that we'll do this way. I need to add 2, so I have 3x squared plus 31x plus 56 is greater than 0. So, I need to factor. Let's see if that works. 24 and 7, that one works. So then I have x equals a negative 7/3 and x equals a negative 8. So take our number line. Now this is not equal to, so these are open, negative 8 and negative 7/3. And we test our regions. Pick a number less than negative 8, negative 10. So I would have 300 minus 310 plus 56. It's positive. Between negative 8 and negative 7/3, negative 5. So this would be 75 minus 155 plus 56. No, that one's going to be negative. And then bigger than negative 7/3, 0. I would have 56 is greater than 0. So that one is a yes. So it's over here and over here. So I have another OR compound inequality. So I have x is less than negative 8 or x is greater than negative 7/3. Okay. And I'll go back. I didn't darken these ones up here. And I'm going to change those. Well, the whole thing I did in X's. These should have been V's. All right, so if you're noticing a pattern, you are correct. These are always going to alternate when you are solving a quadratic inequality, okay? Here is the reason. Let me take you back up to these problems up here. If this had been a 0, look where it's shaded. It's shaded on the outside on the x-axis. Okay? Look at this one. If this had been a 0, it's shaded inside here. It's in between these two. If I look at number 2, if this had been a 0 and I just looked at my x-axis, it's only going to be shaded on the outside of those two x-intercepts. Now, none of these graphs up here had very nice x-intercepts, which that's not what we're concerned about on those graphs, but we are on these graphs, okay? So there's another way of looking at this. This is considered solving algebraically, and if you want to solve these graphically, what we can do is we can visualize what the graphs are going to look like. Okay, you still have to find your x-intercepts. You still have to find your solutions. So I'm still going to factor and solve. So n equals 0 and n equals 7. So if I take a look at this, now think of if you had n squared minus 7n and you were to graph that. It's a parabola and it opens up, okay? Here it's going to be positive, here it's going to be negative, and here it's going to be positive. Well, in this original right here, I have n squared minus 7n is greater than 0. What kind of numbers do I want? I want positive numbers. I want the numbers here, and I want the numbers here. These numbers in between these two are negative. Those are not the numbers that I want. These are the numbers that I want here, and these are the numbers that I want here. So therefore, this is going to be an OR compound inequality. I would have n is less than 0 or n is greater than 7. Okay, let's take a look at another one like that. Oops, minus 21. So this factors into 2m minus 7 times m plus 3, I think. 6 minus 7 is negative 1. There we go. So my two solutions are a positive 7/2 and a negative 3. Now, a common mistake for people to make is they put the first number first on their number line. Remember, on your number line, the smaller number always has to go first. So this is going to be a negative 3, and this is going to be a positive 7/2. All right, so we're going to look at the graph. We're going to take this, would be a positive. So my graph would open up. Those are my solutions. Those are my x-intercepts. So these numbers are positive, these numbers are negative, and these numbers are positive. Well, what kind of numbers did I want? I wanted negatives. I wanted it where it was less than 0. So these are the numbers that I want. I want the numbers in between these two. So this is going to be an AND compound inequality. All right, let's try the last two. Subtract 7, so this is going to be a 48 is less than 0. And then this factors into r plus 6 times r plus 8. So r equals negative 6 and r equals negative 8. All right. Open circles. So this is a positive r squared, so my graph would look like this. So I have positive numbers, negative numbers, and positive numbers. This is above, positive, this is below, they're negative, this is a positive, they are above. What kind of numbers did I want? I wanted numbers that are less than 0. I wanted negatives. So these are the numbers that I wanted. So negative 8 is less than, r is less than negative 6. One more. All right. Factor. $36 Okay, so n would equal a negative 6/5, and n would equal a negative 6. So negative 6 has to go first, and it's closed because it's equal to positive 5. So my graph opens up. These are positives, these are negatives, these are positives. What kind of numbers do I want? I want numbers that are greater than 0, so I want my positives. So I want these numbers here and these numbers here. So this is an OR compound inequality. So n is less than or equal to negative 6, or n is greater than or equal to negative 6/5. Hope that makes sense, and hope you do okay on the assignment.